Have you ever stopped to think about what happens when the power goes out? It's not just some magic switch that brings it all back online. Nope. Deep underground, there's this whole team of invisible detectives that springs into action. So today, we're going to pull back the curtain on these amazing little devices that literally keep our world running.
So just picture this for a second. Somewhere deep beneath the city streets, a critical power cable just gives up. It breaks. Now, this isn't some tiny wire. It's part of a massive network that stretches for miles and miles. You don't see any sparks, there's no smoke, nothing. So how in the world do the utility crews find that one single point of failure without, digging up an entire neighborhood? Okay, so let's set the scene. The problem starts right here, inside the super complex underground loop of medium voltage cables. It's kind of like a giant buried extension cord for a whole community. When a fault happens, and it could be anything, maybe the insulation just wears out and a live wire touches the earth, a timer basically starts ticking. And believe me, the stakes are incredibly high. Without some kind of guide, trying to find that one break is a total needle in a haystack situation. We're talking about days, maybe even longer, of really expensive, disruptive digging, all while leaving thousands of people completely in the dark. There has to be a better way, right? Well, of course there is. And this is where the hero of our story comes in. Meet the Earth Fault Indicator, or as we'll call it, the EFI. This small, pretty unassuming device is basically the silent guardian of the power grid. It's the detective on the case. So, what is this thing really? Well, an EFI is a super specialized monitoring device. It has one job and one job only: to figure out when electricity is leaking to the ground where it shouldn't be, and then, and this is the important part, to signal exactly where that's happening. It's the key that turns a search that could take days into one that takes just minutes. Now, these little detectives, they don't work alone. They're placed at very strategic points all along that cable loop, inside these sealed electrical hubs called ring main units. You can just think of them as super secure underground junction boxes. And together, all these EFIs, they form this incredible network of informants. And each one is constantly watching its own little stretch of the grid, just waiting for a clue. So how does it actually see a fault? I mean, it's not looking for smoke or anything obvious. It's looking for something much, much more subtle. It's looking for a disturbance in the electrical force, if you will. And the absolute heart of our little detective is a component called a core balance current transformer, or CBCT. All you need to know is that it's basically a ring, and all three of the main power cables have to pass right through it. And this ring is incredibly sensitive to one thing and one thing only: balance. This really shows the whole principle right here. In a healthy, normal system, that's what you see on the left, the currents flowing through those three cables are perfectly balanced. They actually cancel each other out, so if you add them up, their sum is zero. The EFI stays totally silent. But look what happens on the right when there's a fault. Some of that current leaks away to the ground, and it shatters that perfect balance. Suddenly, the sum is not zero anymore. And that imbalance, that is the smoking gun our detective has been looking for. The actual detection process is this beautiful, lightning-fast, four-step chain reaction. First, the fault happens, creating that imbalance. Second, that imbalance immediately induces a tiny little current in that CBCT ring. Third, the EFI's brain instantly checks if that new current is strong enough to be a real fault and not just some minor flicker. And if it is, bam, the alarm goes off. Okay, so a single EFI has sounded the alarm. That's great. But how does that help us find the exact spot? Well, this is where that network of detectives we talked about really starts to shine. It's all about following the clues. So let's look at our healthy cable loop again, with 5 of these ring main units. Right now, everything is perfect. All the indicators are quiet, power is flowing exactly as it should, from the source at RMU1 all the way down the line. It's all good. But now, bam, a fault happens somewhere on the cable between Unit 3 and Unit 4. Now watch what happens. That fault current starts flowing from the power source, and as it passes each unit, it trips the indicators at RMU1, RMU2, and RMU3. They all light up red. But since the fault is before it gets to RMU4, the indicators there and at RMU5, they see nothing wrong. They stay normal. Do you see it? We've got a trail. And that brings us to this beautifully simple, elegant piece of logic. The technicians on the ground, all they have to do is find the last unit that has a tripped red light and the very first one that's still showing green. The fault is somewhere in the cable right between them. It's brilliant. Mystery solved. It really all just boils down to this one simple, powerful rule. Indicators upstream of the fault will trip, indicators downstream will not. That's it. This creates a perfect trail of breadcrumbs for the technicians to follow, leading them directly to the problem. So the crews find the break, they fix the cable, power is finally restored. But there's one last thing to do. We've got to get our detective ready for its next case.
And these devices are pretty sophisticated. They have a few key settings you can fine-tune. The trip current, for example, that sets how sensitive it is. And there's this tiny response delay, which is super important because it stops the EFI from crying wolf every time there's a tiny, harmless power surge. And crucially, there are a few different ways it can be reset once the job is all done.
In fact, a lot of these EFIs are smart enough that they just reset themselves automatically. They can actually sense when full stable power is back on the line. When they do, they clear their little red flag and go right back to being those silent, vigilant guardians, just waiting for the next time they're needed. It really makes you think, doesn't it? The Earth Fault Indicator is just one example of all this incredible, invisible technology that's working tirelessly behind the scenes for us every single day. So I guess my question for you is, what other invisible detectives do you think are out there, quietly keeping our crazy, complex world from falling apart?